Hello and welcome to Chemistry Nuggets, where you can polish your knowledge and clear your doubts. So friends, today's video is about displacement reactions. Is it single displacement reactions and it will be double displacement reactions. So let's start the video. But before starting, let me remind you, please subscribe the channel and press the bell icon so that you will get the notification for the next coming videos. So friends, first of all, we will discuss the single displacement reaction. So the definition says a reaction in which more reactive element displaces the less reactive element from its salt or compound is known as the displacement reaction or just single displacement reaction. So let's have a picture here where there are two reactants X plus ZY. These are two reactants where we can say X is more reactive than the metal Y. So X and Y are, if we take an example of metal, X metal is more reactive than the Y metal. What will happen? X will replace the Y from its salt YZ and takes its place. So X move to Y place and it will make XZ product, which is a single displacement product, and Y is left alone, that is displaced outside from the compound. So this kind of reaction is also known as substitution reaction. That you will learn later in organic chemistry. One more point to be noted is when there is a displacement reaction takes place, always highly reactive metal will replace the less reactive metal, or highly reactive non-metal will replace the less reactive non-metal. So it will be X, it should be metal or non, but metal to metal and non-metal to non-metal. This reaction goes like that. Let's have a look on the example. If we have copper sulfate solution, copper solution, and we put iron nail in that. Fe means iron. What will happen? Iron is more reactive than copper. Copper is having a compound form copper sulfate. So iron is more reactive metal than copper metal. So iron will replace the copper from its salt and makes the iron sulfate. This is ferrous sulfate, and copper is removed and which is collected on above the iron nail in the form of copper crystals. So when we are talking about the more reactive and less reactive metal, how could one know which is more and which is less reactive? For that we have a reactivity series of metals. So it is a series where we can see and check which metal is more reactive. So this reactivity series is going decreasing from up to down. So this is decreasing. That means the metals on the top are more reactive than the metal which are on lower side. So let's use the reactivity series and solve some displacement reactions. So here we have a reaction between copper and silver nitrate. This is our silver nitrate in aqueous form. So in the reactivity series we can see that copper is above than silver in the series. It means copper is more reactive than silver. So copper will replace the silver from silver nitrate and takes its place. So it will make copper nitrate, and the silver is left, which we can see easily. So this is the use of reactivity series. Second, let's have one more example. Here potassium is added to magnesium chloride. This is our magnesium chloride. So potassium and magnesium are two metals. Let's see, potassium is on the top. That means potassium is highly reactive, the most reactive element. And then comes the magnesium somewhere below it. It means potassium is more reactive than magnesium. So potassium replaces the magnesium from magnesium chloride. That means potassium will take the place of magnesium and makes the potassium chloride, and magnesium is left behind. Now one more example, which is for non-metal. So here chlorine is added to sodium bromide. Here we can say sodium is the only metal, and here we are two non-metals, chlorine and bromine. So here we will work on the non-metals. So here non-metal will replace the non-metal. And for the reactivity series of non-metal, chlorine is highly reactive, then comes bromine, then comes iodine, like that we will use. So chlorine is more reactive than bromine. It means chlorine displaces the bromine from sodium bromide and takes its position. Now what will happen? Sodium bromide will break and chlorine will be taking the place and makes sodium chloride, and bromine is left behind in the aqueous solution. So this is all about single displacement reaction. Let's come up to double displacement reaction. So reaction in which there is an exchange of ions takes place between two reactants is known as double displacement. So what is happening here? Here displacement is going on, but not one time. It is two times. Means two compounds in the aqueous form. If we add both together, the ions takes the place of other compound and they will exchange their ions. So point to be noted is, first of all, this type of reactions occurs only in aqueous solutions. One more point to be noted is, this type of reaction, double displacement, is also known as precipitation reaction. Precipitation reaction. Now, why it is called precipitation reaction? Because when double displacement takes place, there is a formation of precipitate, that is something undissolved settled down in the form of powder, or we can say something which is settled down is called a precipitate. And most of the time in double displacement, precipitate is formed. So let's have an example. We have here sodium sulfate in the aqueous form. Plus we have barium chloride. Barium chloride. Now here what will happen? Sodium will take the place of barium and barium will take the place of sodium, and they will exchange their places, and in result barium sulfate is formed. and sodium chloride is formed. And this barium sulfate is in the form of precipitate, which is collected just at the bottom of the test tube. That's why these reactions are called precipitation reactions. So that's all for today. Hope you guys like the video. Please press the like button if you like the channel and video. Thank you.